Assalamualaikum warahmatullahi wabarakatuh. Greetings, Pak Zul. Today we're from Mahasigma Group. We would like to present our midterm projects on multiple linear regression on CDR ratio for glaucoma diagnosis. But firstly, before we start, I would like to introduce our group. My name is Salsabila, followed by my partner Hani, Raisa, Tifali, and also Siti. Next. Okay, so firstly, for our introduction, so glaucoma is a progressive eye disease affecting in the optic nerves and then also often resulting in an irreversible vision loss. And then multiple linear regression can help on detecting the glaucoma using to predicting the outcomes, identifying key factors, quantifying the effects, controlling confounders, and then also assessing the model fits. Next. Okay, so for our research, we have this the flow on this diagram that we divided into three part, which are pre-processing, assumption checking, and then processing and analyzing. Okay, so for problem formulations, we have three main problem to be looked at on our research, which are challenge in accurate glaucoma diagnosis, application of multiple linear regression in analyzing the CDR ratio, and then also detecting the glaucoma diseases factors with the regression model. Therefore, our key question for our research are the first one is, does the linear regression model used in CDR analysis in glaucoma patients meet the applicable assumption? And then the second one is, what factors affect the cup to disc ratio or CDR in glaucoma diagnosis using the fundus image? Therefore, our research objective are analyzing and then also presenting the influence of factors such as eyesight and then also the glaucoma to the CDR ratio in the diagnosis. Next. Okay, before conducting the research, we do a literature review. So, as you can see, that glaucoma affects 1.5 until 2% of the individuals over 40 years old, and then also up to 4% of those that are already in 70 years old. And then therefore glaucoma needs a really early detection. And then glaucoma use fundus imaging for the detection. And then so cup to disc ratio are a critical parameters in diagnosing and assessing the progression of the glaucoma. So CDR has a normal ratio on 0.3 until 0.4, and then for the glaucoma CDR is more than 0.6. Therefore, we have four main challenges. Next.
Okay, now that we have understood the basics of glaucoma disease, we can dive into the dataset overview. We actually use the dataset that we acquired from a paper titled An Online Retinal Fundus Image Database for Glaucoma Analysis and Research from 2010. It was based in Malaysia and Singapore, and actually, from the start, the researchers examined around 3,000 Malaysian adults, resulting in around 6,000 database image, but was then reduced to 650 data for the research. And each of their image is defined by four variables. The first one is the dependent variable, which is the cup-to-disc ratio, and the rest of the three variables is the independent variables, which are that tells us whether the image was of the right eye or the left eye, and then the set variable, which tells us who examined the database image, and the third one is the glaucoma variable, which tells us if the image is glaucomatous or not. And as you can see here, actually the only numerical variable we have on the research is only the dependent variable, and the rest is categorical. Okay, moving on to the methodology, we of course use the MLR model or equation, where the dependent variable is the y factor and the rest of the three is the x factor, representing the independent variables. We also conducted the assumption baseline for any multiple linear regression research, which is the linearity test, normality test, multicollinearity, homoscedasticity, and the independency test, all of which you can see the hypothesis on the screen. Okay, before we dive into the analyzing, we actually have a phase of cleaning the data first, where we look for three main values in the data set. The first one is the missing values, the second one is the duplicates, and the third one is the outliers. For the first one, we detected that there was no missing values in the data set, and for the second one, we we got a result of 16 duplicates, which we then removed, and then it was 634 rows after. The next is the third one, which is outliers. We detected the outliers using the coding, which you can see that tells us the number of outliers in the dataset is the exponential CDR ratio. They have 53 outliers, which you can see also the visualization in the box plot. Uh, then we remove the outliers using the coding available, and you can see the reduced box plot in the screen also. The rows after we do this phase is 581 rows.
The next one is the dummy variables making, and it is necessary in MLR to have dummy variables as it converts categorical data into numerical form, allowing MLR regression to properly analyze and interpret the impact of categorical variables. And from our data, we changes the glaucoma um, from yes and no into one and zero. And for these two data here, the I and Z, we also changes from OD to OS and A to B. And before, the I and Z have 650 rows, but after we cleanse it, it becomes 581. So all the data here are numerical. The next one is the linearity test. It is to use to see if there is a linear relationship between the independent and the dependent variable here. And you can see from the left graph, it is the correlation graph of each independent variable with the dependent variable. And from this graph, we can see that there is a positive linear relationship with the CDR because there is a distinct pattern in how the expected CDR values is distributed between the two binary data, indicating that there is a possible association between those variables. And the right one it is the observed versus unobserved chart predicted values. And from this graph, we can see that the pattern here of the scattered data is linear. So it meets the linearity of the assumption. The next one is the normality test. It is used to see whether the residual values of the data are normally distributed or not using the Anderson-Darling test. These are the code that the result of the code that we first test. And the key takeaways here, in Anderson-Darling test, we see that the statistical value is 0.4690, which is bigger than the critical value, which is 0.7821. And here, we can see that the p-value surpasses 0.05, indicating that the HO here is accepted and the data is normally distributed. And on the right side, we can see from the scattered, the probability plot, where the data tends to be spread around the red line. So from here, we can see that the HO is accepted.
Our third task is we're using independency test to detect the presence of autocorrelations in the residuals of a regression analysis. So for the test, there is assumptions regarding the residuals or independence, and it's indicating no correlation between them. And for the statistic range, if it's at 0, it suggests evidence of positive serial correlations, and if it's 2, it indicates no serial correlations, and if it's 4, it indicates evidence of negative serial correlations. And in independent site tests, we're using Durbin-Watson test, and the result of the statistics is 2.04. So it indicates that there are no significant autocorrelations among the residuals, which suggests that the residuals are independent and the assumption of independence is met. And the null hypothesis is accepted, so all variables are independent and there are no correlations. Next. Next, the fourth test is multicollinearity test that used for assess the presence and severity of multicollinearity among independent variables in a regression model. There are two variance inflation factors. The first one, if the VIF equals to 1, it indicates no correlations between the independent variable and other variables. On the other hand, if the VIF less than 5 or 10, it suggests high multicollinearity among the independent variables, warranting further investigations or remedial measures. And based on our test result, it shows that all variables in the model have a VIF below 5 and close to 1, indicating no significant multicollinearity and no hypothesis is accepted. So this is suggests that the independent variable set I and glaucoma are uncorrelated, allowing for reliable interpretation of their individual effects. Next. Our last test, we're using homoscedasticity test, and there are two types. The first one is homoscedastic that indicates residual data has constant variance, suitable for ordinary least squares or OLS regression method. And the last one is heteroscedastic that indicates residual data has non-constant variance, less suitable for ordinary least squares or regression method. And the result of the test, it indicates in the image below. So from that, it indicates that the p-value is 0.871 and it's more than 0.05. So it's conclude that the null hypothesis is accepted and the homoscedastic occurs. Next. For our discussions, we're using multiple linear regressions result interpretations. So in here, we can take a look for the R-squared coefficients. And from the result, it's indicate all of the independent variables have a positive impact on the dependent variable, which 0.1731, 0.1734, and 0.3014 coefficients each. Meanwhile, the coefficients in dependent variable implied it will be negative if independent variable are 0. Next is about standard error. So from the result, the standard error of 0.004 and 0.005 is for the estimation reflects the extent of variations around the estimated regression coefficients. And moving on to the t-value, so the higher the t-value, the lower the likelihood that the result occur by chance. And the actual result, if the t-value more than 0.05, it does not have significant impact. Meanwhile, if the t-value less than 0.05, it does have significant impact. And the last one is p-value greater than the absolute value of t to t test. So there are three scenarios. If the x1, x2, x3 less than 0.05, so the null hypotheses are rejected. So from all of the results, the key takeaways are all of the independent variable have a significant impact on the dependent variable y. Next.
Next, moving on to the discussions of the R-squared coefficient and the f-statistic value. Here we have the assumptions, which is 0 indicates the weak fit of the data and 1 indicates the strong fit of the data. And here we identified that the R-squared is 0.92, which is close to 1, which indicates that 92% of the independent variable can explain the dependent variable. Whereas for the f-statistic value, for the value more than 0.05, it indicates that the independent variable has significant impact, while less than 0.05, it indicates that it does not have any significant impact. And here, with the value of 2217, it is larger than 0.05, which the key takeaways would be the independent variable has a significant impact, therefore the model is considered good. Next. Here we have the conclusion of the impact of eye, SAT, glaucoma on the CDR in the MLR. So the MLR model would be as stated in the presentation, in which X1 is a representative of the eye, X2 is a representative of SAT, X3 is the representative of glaucoma. And based on the coefficient, the further to the right, the more positively it influences the CDR. And then coming off to the R squared before, that 92% of the three variables has a distinct and independent influence on the CDR with no significant correlation between them. And for the F statistics, the independent variable has a significant impact, therefore the model is considered good. And based on the p-value for the eye, SAT, and glaucoma, which is less than 0.05, indicates that all variables have a significant impact on the dependent variable y. And then for the assumptions, the regression model satisfies all 5 assumptions, including linearity, normality, homogeneity, independency, and multicollinearity. So in summary, the MLR model shows that the eye, SAT, and glaucoma significantly impact the cut-to-this ratio, or CDR, with 92% variance explained, confirming its reliability for predicting glaucoma risk while satisfying all regression assumptions. Next. I think that would be it for our presentation. Here are our references, and that would wrap up our presentation for today. Thank you, Padzo, for having us.